Hello, budding doctors of United Kingdom. I'm here with my new video on BMAT Section 2, Scientific Knowledge and Application. So let's have a look at today's question. So this question is on waves. So this is all about microwaves, and you see they're asking you to calculate wavelength and frequency. So the question says, the microwaves generated in a microwave oven travel through air at a speed of 3 times 10 raised to the power 8 meter per second with a wavelength of 12 centimeters. So the speed is given and the wavelength is given. They pass through plastic food containers, but at a reduced speed. Of course, you know that when waves pass through a denser medium, they slow down. So they pass through plastic food containers, but at a reduced speed of 2 times 10 raised to the power 8 meters per second. So they're asking you, what is the wavelength and frequency of these microwaves as they pass through a plastic food container? So that's the question. When they pass through the plastic food container, what is the wavelength and frequency? And they have given multiple options. You see, you're given wavelength, you are given 8 centimeters, 12 centimeters, 18 centimeters, and of course there are around 7 or more than 7 options for frequency. So what's the right answer? So let's go over the solution for this question. All right. Now you see, you need to know the equation for velocity. Velocity is frequency times wavelength. You are given the velocity in air and you are given the wavelength in air. So what you have to do is, the first thing you need to do is to calculate the frequency. So what you can do is you could use the formula V is equal to F lambda, that is velocity is frequency times wavelength, and calculate the frequency. Make frequency the subject of the equation, rearrange this equation, and first make frequency the subject of the equation. When you make frequency the subject of the equation, you get frequency is velocity over wavelength. Now the velocity was given as 3 times 10 raised to the power 8 meters per second, but the wavelength was given as 12 centimeters. You have to convert centimeters to meters first. So if you want to convert centimeters to meters, you get 12 times 10 raised to the power negative 2, because 100 centimeters is 1 meter. So what you are doing is you are dividing this by 100. And when you do a little bit of calculation here, I can tell you a quick way of doing, because here you see it's 3 times 10 raised to the power 8. So all I can do is I can write 30 times 10 raised to the power 7, and this is negative 2. Applying the laws of exponents, this goes up, and this was 30 times 10 raised to the power 7 plus 2, which is 30 times 10 raised to the power 9 divided by 12. And 30 divided by 12, that gives you 2.5 times 10 raised to the power 9 hertz. So you got the frequency. One thing you need to know, that frequency never changes. This is a very important statement. Frequency never changes. When waves travel from one medium to another, like if the waves are traveling from air to glass or air to plastic container, its velocity will change, its wavelength will change, but frequency never changes. Why? Because frequency depends on the source that produces the wave. Frequency doesn't change on the medium. Like if the medium changes, frequency doesn't change. So keep this in mind, frequency always remains constant. Now, once you have calculated the frequency here, the frequency in the glass container or the plastic container will still be the same. But we don't know what is the wavelength in the plastic container. So what we'll do is, we will again use the formula V equals to F lambda, and this time we'll make lambda as the subject. And when you have velocity is frequency times wavelength, and you make lambda as the subject, you get lambda is velocity over frequency, and that would be 2 times 10 raised to the power 8 because the velocity of the wave in the plastic container is given to be 2 times 10 raised to the power 8 divided by the frequency. So the frequency we just calculated 2.5 times 10 raised to the power 9, and frequency remains constant, it never changes. So the frequency in the plastic medium would still be 2.5 times 10 raised to the power 9. And when you divide this, you can do a little bit of math here, and you will see approximately you will get 8 times 10 raised to the power negative 2 meters. And that would be 8 centimeters. I did a math here. You see 2 times 10 raised to the power 8. And what I did was I made 20 times 10 raised to the power 7. And this is divided by 10 raised to the power 9. And applying the laws of exponents, it is 10 raised to the power 7 and divided by 10 raised to the power 9. That gives you 10 raised to the power negative 2. And 20 divided by 2.5, that gives you 8. So it is 8 times 10 raised to the power negative 2, which is 8 centimeters, because 8 times 10, 8 times 10 raised to the power negative 2 meters is 8 centimeters. So if you go back to the question, you will see the wavelength 8 centimeters and frequency 2.5 times 10 raised to the power 9 hertz is the option B. So let's go back to the question now. And you will realize that your option B is actually 8 centimeters, the wavelength, and 2.5 times 10 raised to the power 9 hertz. That's the frequency. So this is how you solve this question. I hope you enjoyed this video. And if you like this video, uh, kindly click on the like button and also subscribe to my channel so that you get future videos every time.